Have you ever felt?
Are you listening? Damn. Yeah. Yeah. Yeah.
Hello guys, so in this video I will be explaining you about how to do different kind of visualization of data using R and the library ggplot2. So I will also explain in this video that what is numerical variables and what are categorical variables. So let's begin by importing the library ggplot2. If you have not installed it, you should install it using the command install.packages ggplot2 and then select and then hit control enter. Now import this library ggplot2 and the library mass, and then store this birth wt dataset in the object data frame. So this is the dataset which we are going to visualize using the library ggplot2. So there are 189 observations and 10 variables or 10 columns, out of which some will be numerical and some will be categorical. So how to see that which of these are numerical and which are categorical? What you can see, either you can read the data and then make sense out of it to see that which of these are numerical and categorical variables. So just write help birth wt, which is the name of the data set, and on the right hand side you can see that there are meanings of each of these columns: low, age, lwt, race. So if you click here, you see that these are the column names and 189 observations are there. So if you click here on the age, the minimum value is 14 and the maximum value is 45, and you see that it is continuously varying. Lot of unique values are there: 32, 34, 35, 45. So starting from 14 till it is 45. And then if you see race, it is also there are numerical values, but this is not a numerical variable, because if you see that race is mother's race, which is encoded values as 1 if race is white, 2 if the race is black, and 3 if otherwise. So this is just encoded values, and encoded values can be numerical and can be character variable, can be character values. So you could encode white by A, black with B, and other with C, but here it is encoded as numerical values. So you should not be confused that race is a numerical variable. So you should know that race is a categorical variable. In the smoke is 0 when the person is not smoking during the pregnancy, and if she's smoking, then it is 1. So now if you see the BWT, which is also a birth weight in grams, in the right hand side you can see that BWT is birth weight in grams. So minimum value is given 709 and the maximum value is 4990. Just click here on BWT and check the minimum and maximum values. So BWT is again a numerical variable. LWT, age, these are numerical variable. Rest of them seems to be categorical, and they are so race, smoke, PTL, HT, because there are only 1 or 2 or 3 unique values, and they seems to be categorical because we cannot subtract them, like race 1, 2, 3. So you cannot subtract race is equal to 3 minus 1 because it does not make any sense. So this is numerical and categorical variables. If you want to see the number of unique values in each of the columns, so just write this function: sapply data frame function length unique x If you don't know about this, I have already explained in my first video in this course how to use supply. So just select this. You can see that number of unique values in age is 24 and BWT is 131 and LWT is 75. These three are very high values. So, and this is a numerical variable, and race is a categorical variable. So for distinguishing between numerical and categorical variables, you need to read the meanings of the variables in the data set, and also you can check the number of unique values in each of the columns. So now let's convert. So to treat the categorical variables, you should convert the categorical variables into factor variables. So just select write data frame $LOW as dot factor and write this. So all these will be converted into factor variables. So in this video I have just explained you what is numerical and what is categorical variable. You have imported the data set and you have seen that which of these are numerical and which of these are categorical variables. In the next videos I will be explaining you that how you can do the scatter plot, bar plot, histogram and density plot and different kind of visualizations. For say if you have only one numerical variable, what you can do. If you have two numerical variables, what are the possibilities, and if you have one categorical variable, what you can do. In that way you can I will be explaining in each of these that how to create a plot for each of the combinations of continuous variables or and categorical variables. So in the next video I will be explaining you about the scatter plot. So thanks for watching this video. Hello guys, so in the last video I have explained you about this data set birth WT. If you have not, please have a look on the last video where I have explained you numerical variables and the categorical variables, because this video is linked with that video. So in the last video I just converted the categorical variables into the factor variables, but right now I am just considering one numerical variable, and I am trying to explain you that how you can plot one numerical variable using ggplot2. So say in this data frame, the data name is data frame, and in the right hand side you can see 189 observations and 10 columns. So I already explained age, LWT and BWT. These are three numerical variables, and I will be choosing one of these and I will show you what you can do with that. So one of the things which you can do is to plot a histogram. So let's take age and then plot a histogram. So in the histogram what you get to see is that if you see the minimum value is 14 in age and in the maximum value is 45. So in histogram you can see the distribution of this variable, where it shows that in which range of age what is the number of observations lying in that. So if you see on the right hand side, the histogram is available for the age, which I have already plotted using some code. I will be explaining in few minutes about how I have plotted this. So if you see here that there is a huge peak around 25, so it tells that the distribution and the minimum value is 0 and the maximum value is 50. Only few observations are lying above 35 or so. See, here is blank space between 35 and 45. So number of observations which are lying which are maximum present are between 20 to 30. You can see a peak here, and observations lying below 20 or below 15 is very less, and observations lying above 30 is very less. Most of the people are lying around 20-25. So this was the data for mothers who were pregnant. It is very obvious that the ages group will be around something around 25. So it is a distribution of ages of the mothers. You can have a look on the data set what is the meaning of that. Irrespective of what is the meaning, you just have to see that this age distribution which is shown here is something like this. And how to plot this age variable, you can see here is what you can see. Now you have to use the function ggplot, give the data name as data frame, and geom underscore histogram, and aesthetics you have to give the x-axis, means we are only taking one numerical variable at this point of time, and the numerical variable which we are taking here is age. So you have to use the geom underscore histogram. So everything, whenever you change the type of plot, you have to just change here. Instead of geom, you write geom, ab line, area, bar, bin, point. So many options are available. You have to just write geom underscore and hit tab. You will get all the options available. Right now I am just using one variable, which is age, which I will be giving under the aesthetics, right? X is equal to age. For the histogram color, you just write blue, and the x-axis I am taking continuous. That's why scale is being chosen as x scale underscore x underscore continuous. You can also change the y axis, but right now I'm just changing the x-axis. And name of the x-axis I have changed to age, and the breaks which I have taken for the x-axis starting from 0 and going till 50, these are the ages, and spacing of 5. So it is obvious that the ages lesser than 50 is very less, and also ages above 50 is also they are not present, but I am taking a spacing of 5. You can choose any spacing here. So if you want to give the name to this plot, what you can write inside this GG title, and the label is equal to histogram of age, and the background you can change. You can choose, there are many options. What you can do is just write theme underscore and then choose one of these. Right now I've chosen BW. So these are the things. There are many other parameters and arguments which you can tweak. This is the minimum which you should know if you want to plot a histogram for one numerical variable. So this is a very starting point when you have one numerical variable and you want to see the distribution, how it is distributed. Right now it is the distribution of age. So just give the name of data frame, inside which what is the column name, it is age. You have to write it here, and you can change the x-axis name here and change the x-axis spacing here, starting value, maximum value, and the gap. You can change the plot name here, and you can change the background here. So this is all you need to write, and just select this and hit enter. So here you can see that this is replicated again, and you can zoom it to see the distribution of age. So this is for one variable which you can do. Another is what you can do is density plot. Just copy this, Control C, Control V. Instead of writing histogram, what you could just write density, and then just Control Enter, and you can change here density plot of age, and just select and Control Enter. Here you can see the density plot. So it is also telling that where the maximum number of observations are lying, around 20 to 25, the maximum number of observations are lying, and ages above 30 is very less, and ages below 17, 18 is very less. So it is tapering down. The mean value is something around which you can see here, between 20 to 25. So this is all about the density and the histogram. So if you have one variable, you can plot these two, and you can do other things also, but this is the basic. In the next video I will be explaining how you can see the relation between two numerical variables, and how you can plot the categorical variables also in the next videos. So thanks for watching this video. Hello guys, so in this video I will explain you about how you can treat the two numerical variables if you have in the data set and what you can do with that. So the best of what you can do with the two numerical variables is to check the correlation, and for visualization purpose what you can do is you can plot the scatter plot. So what is a scatter plot? It is just the observations in the x-axis. You choose the x-axis and the y-axis. You can do a 2D scatter plot or the 3D scatter plot. Right now I'm showing you the 2D scatter plot. So in the 2D scatter plot you choose any two numerical variables. This is a video for two numerical variables. What you do is that in the last video I have explained you that you have to put the data frame in this data argument, and then instead of writing geom underscore histogram, right now what you will do is just write geom underscore point, and you have to give the two names now because we are taking two numerical variables. One is x-axis and the y-axis. So age numerical variable and the y is LWT numerical variable. Color you can choose of the data points as blue, and the size of the data points to be, you can choose according to the number of observations you have. So you can choose 2 right now, and alpha is actually the transparency of the data points. So if there are a lot of data points overlapping with each other, what you can choose is transparency. So you can make the data points to be transparent so that you can look through the data points, because some of the data points may be overlapping with each other. So if you reduce the transparency, it will be better to have a look on the observations. Otherwise you won't look the observations which are overlapping on top of each other. So you can tweak these parameters. Color you can choose yourself, size you can choose, alpha also you can choose yourself. On the x-axis you can choose as continuous, because it is, you can choose either discrete and continuous. If discrete is mostly used when you have integer values, and continuous is used when you have decimal values also. I have chosen right now as continuous because it makes more sense to take it as a continuous. And now the x-axis, the name is age, and the y-axis name is written as LWT in the y, and the breaks you take is from 0 to 50 and 5, and LWT ranges from 0 to 300 and with a spacing of 50. So for age it ranges from 0 to 50 with a gap of 5, and LWT, which is the weight, ranges from 0 to 300 with a spacing of 50. You can give the name of this plot here, age and LWT, and this is a relation, or you can say that it is a scatter plot, and you can choose the background of this as theme underscore BW. I hope you have understand this, where you just have to give the 3 parameters. One is the data, which is here, which is data name is data frame, whatever you make it, but here right now it is the data frame name, and the geom underscore point you have to give the x-axis name and the y-axis name, and then you can give all these values and just select this and hit Control Enter. You see the scatter plot here. The name is here on the top, relation between age, LWT, x-axis name is there, age, y-axis name is here in LWT, and 2D scatter plot is here. You can see that we have the data points lying all over here. What we can see here is if there is a relation between them, sometimes they are very following some linear train. Right now we cannot say too much about it because there is not much of some relation in this, but of course you can see the distribution in, if the age is increasing, does LWT increases or not. But there is, if you fit a line in the middle of this data cloud, you can see that line is going straight above. There is some relation that it is increasing trend as the age is growing, that LWT is also growing a little bit. So there is a correlation, but we are not focusing on that correlation factor right now. What we want to do is just to do the scatter plot of these two variables, numerical variables. So I think it is clear that if you have two numerical variables, what you can do is you can use the geom underscore point function, and then you can plot these two numerical variables. In the next video I will be showing you that if you have two numerical variables and one categorical variable, how you can see the relation between three variables at a time. So thanks for watching this video. Hello guys, so in this video I will explain you about when you have two numerical variables and one categorical variable, what you can do. Simplest thing which you can do is to plot the scatter plot for the two numerical variables, and for the categorical variables what you can choose is to color the data points by the categories of the categorical variables. Say we are taking two numerical variables, one is age and LWT, and we are taking one categorical variable which is race. We already know that race is 1, 2 and 3. These are three categories in this data set. What you will do prior to this, we were doing two numerical variables, we wrote this code. Now when we include this race, what you can do is just instead of writing color is equal to blue, what you do is you just write as dot factor, and then what you can write here is, instead of writing here, what you can do, just go here inside and color is equal to as dot factor race. So this is what you can write, and rest will remain the same. So it's very clear. On the right hand side, what is, you can zoom in, you see that three categories, 1, 2 and 3, we have three colors, and earlier we were having all the data points being colored as blue, but right now we have three categories and data points are colored by race. So we can see that these data points of which race, and these data points are of which race, and depending on the colors. So this way what you can do is you can see that race categories have which ranges of age and which ranges of LWT in one plot. If you include, instead of race, if you include the smoke factor and just write as dot factor smoke here, and now just control C here. Again, if you see the smoke, 0 this color and 1 is this. In this data points, you can see that which one of these are smoking and which of these are not smoking. Colored, these data points are being colored by the categories of smokes, those who are smoking and those who are not smoking. So this is to find the relation between the age and LWT, and also the smoking, taking into account the factor smoke. In the next video I will explain you more about how to include more and more variables, but before that I will also be explaining if you have one single categorical variable, how you can treat it, and how to treat with two categorical variables, and how to treat more than that. So I think this is clear for now, that if you have two numerical variables, you can give it here and you can just color it with this. There are a lot of combinations, possibilities you can do. What you need to do is just take this data set and hit and try and see that it doesn't make sense. And you can also have different data sets to have find the patterns in the data. So thanks for watching this video. Hello, so how you will treat when you have two numerical variables and say you have two categorical variables? Can you plot in one? Is it possible? Of course it is possible. Numerical variables, there is no constraint, but for categorical variables, if the number of unique values in categorical variable is very high, then it might not be possible, because say smoke is right now it has only two unique values, 0 and 1. say if any variable has say 100 unique values, then if you choose 100 colors, it won't be very easy to distinguish between the data points by the colors. So if you have lesser number of unique values in the categorical variable, of course this is helpful to distinguish the patterns in the data. What right now we are choosing two numerical values, which are age and LWT. In the last video I have chosen one categorical variable which I plotted using color. Now I'm including one more variable, race, together with the smoke, and we want to see the interaction of all these four variables in a single plot. So what you can do is, you gave the X name, you gave the Y, which are the numerical variables, you gave the data name, which is data frame, you colored the data points by the smoke categorical variable, size you have given, alpha you have given, rest is same. Now you want to include the race variable. How you will include this? It is what you can do. You can change the shape of the data points. So race is 3 categories. What you choose, one more parameters is here. Just write comma and hit tab, and you will get the options, but right now you cannot see here, but you can write shape is as dot factor, and what you can write is race. Rest will remain the same, and just select everything and control enter. Right hand side, zoom it. You see that for the race we have 3 shapes: circle, triangle, and there's a square. For the third category it is a square, for the second category it is triangle, and for the first category it is circle. So data points are shaped by the race and colored by the smoke. So you can again try to figure it out, what are the interaction between the race and the smoke, where are the race belonging, and where in that race where are they smoking or not, and what is the age and what is the LWT. When the data is very clean and there is significant patterns inside that, it is very easy to see that one of this triangle are making a cluster on the right hand side, and the square brackets are making some cluster and on the left hand side. So they are very distinguished clusters of different shapes. Right now it is obvious it is not very some pattern in this data set, but when there is some pattern, all these will be different clusters segregated together. So I think in this so we have included now 2 numerical variables and 2 categorical variables to see the pattern in this data set. In the next video I will explain you more about how you can change more of these plots, and you will get to know about how you can color the density plots by different categories and all those things. So thanks for watching this video. Hello guys, so in this video I will explain you that how you can treat if you have only one categorical variable. In the last video I have explained you that how you can treat a numerical variable. You can either plot a histogram, and but for a categorical variable, instead of plotting histogram, you have a bar plot where you tell about the number of the counts of each categories, the number of observations which are lying in the each categories. So let's take one of the categorical variable, and please remember, whenever you have categorical variable for data visualization using ggplot2, you should convert into the factor variable. So we have already converted low, smoke, race, PDL. These are all categorical variables, and we have converted them into the factor variables using the function as.factor. So let's take a simple example of race category, which has 3 categories, and we want to see using a bar plot what is the distribution of each of these categories, means how many observations lie in each of these 3 categories. Earlier I explained you for the histogram, it is similar. Just instead of writing geom underscore bar, geom underscore histogram, you write geom underscore bar, and x-axis you write the variable name. Instead of writing numerical variable name, you will write the categorical variable name. So right now I am choosing the race category, race variable which has three categories. I will be writing the race variable name in the x value. So x is equal to race, and rest will remain the same as I explained in the geom underscore histogram. So just do like this, select this and hit enter. So sorry, here is one bracket missing. It is always you should do the escape button to just escape out of this when you are stuck in this, if you are missing some round brackets. So you should always take care of these brackets, because if you miss one of those, then you may be not the plot will not be visible on the right hand side, and there will be plus sign on this left hand side, you can see, which is left. Otherwise the cursor will be back to the console. And so let's again select this and then control enter. Here you can see that we have three categories of the race, and we have mostly the persons are from the first category, and the least persons are from the second category. And so we can, from here, from the bar plot, we can see that which categories have more observations in the data. So this is for the one categories where you can just use a simple bar chart. In the next video, I will be explaining you how you can use more categorical variables to find the information in the data. So thanks for watching this video. Hello guys, so in this video I will explain you that, say if you have some categorical variables, say smoke. Earlier I explained you that how you can create a bar plot of it. Bar plot is nothing like, it is just telling about the number of observations in each of the categories. So smoke has only two categories. It is 0 or 1, either it is a smoking or not. If it is a smoking, then it is 0, it is 1, and non-smoking is 0. So I already explained that this code. You select this and control enter, you see the plot here. It is just telling that the smokers and non-smokers distribution, that the smokers as one number of observations are lesser than the non-smokers. So the smokers are lesser than non-smokers, and how much you can see that's by the numbers of observations here. Now what we want to see, we want to say we want to distribute these smokers among the races. We want to see that in which race the relation between race and the smoke. So we want to see inside this 0th column, between 0 to what is the fraction of each of the races, and in this one column smoke is equal to 1, this smaller column, what is the distribution of races inside this. So this can be easily done here. What you need to do is just write the same code, but just write comma and write fill. We are using now fill, not coloring, because these are not data points. We have to fill the rectangles of these bars. That's why the argument being used here is fill instead of color, size, shape, or so I will be telling you that you have to, whenever you are dealing with rectangular bars, you should use the fill instead of colors. So now you write as.factor and just raise, and now you have two variables here, and just control select it and then hit control enter. You can see what you can see here is that when the smoke is 0, what is the distribution of rays? So you can see that the blue is larger fraction of this complete rectangle on the left hand side, and then the smallest fraction of this non-smokers is green, which is the 2 category in the rays. So it is visible that inside this columns, the higher fraction is of the third category of the race. In the smokers, you can also see that red is quite high. Red is quite high, much higher than the blue ones. So in the smokers, you can see that the red race is having high smoking as shown in this data set, and the green and the blue is equally likely. So green and blue categories of race, they are equally likely in the smoking. So this is how you can treat two categorical variables. So you can just plot bar plot of one categorical and fill it with the other categorical variable. Next video I will explain you more about how you can deal with more and more variables. So thanks for watching this video. Hello, so in this video I will explain one more function which is being used for including more than 3 or 4 numerical and categorical variables at a time. Right now let's just take 3 categorical variables. One of those is a smoke, low and race. So these are 3 categorical variables. So smoke is 2 categories, low is 2 categories, 0 and 1, and race is 3 categories, 1, 2 and 3. So we have 3 categorical variables which we are taking into account. Earlier I have already explained you that how to plot a bar plot for a single categorical variable which is given below. ggplot, give the data argument and geom underscore bar and x is equal to smoke. Just write this and then select this and hit control enter. You see here we have for 0 and 1. So from the data it is very clear that the smokers are lesser than the non-smokers. This is very clear here. But now what we want to include is, say, the low variable, or say we want to see this thing, distribution of a smoke 0 and 1. We can see that the smokers are lesser than the non-smokers. Let's see that if it is true for all the race categories or if it is only true for one of these categories. For that, what we can do is we can plot the same thing for separately. What we can do, we can use the function plus facet underscore wrap and write tilde and write race. Now again select this and hit control enter. Now you get 3 boxes for each of the 3 categories. So 1 box, 2 box and 3 box. So first box is for the race is equal to 1 category and race is equal to 2 category, and the third box is race is equal to 3 categories. So it is clear that for race is equal to first category, the smokers are more than the non-smokers. In the second race category, both are equally probable, and in the third race category, the non-smokers are quite higher than the smokers. So from this kind of visualization, it is very obvious to see that for different race categories, what is the distribution of the smoke categories. Earlier we were just having the smoke distribution across the whole population, but right now we are now dividing the whole population into 3 categories, which is race categories, and it's clear that from the first race category have more smokers than the non-smokers. Now let's include one more variable, which is the low variable, and first let's see what is low variable. You can just see help birth wt. On the right hand side you see the low is indicator of birth weight less than 2.5 kg. If the birth weight is less than 2.5 kg or not. I would suggest to please read all these each of these variables so to make more meaning in this data set. So this is the indicator of birth weight less than 2.5. So let's include this variable here. Two variables are already included. Smoke is included here, which is telling about the distribution of that smoke, number of observations in each category, and we have three boxes for rays. Now what we do is, after smoke you write fill is equal to as dot factor low. Now select this and hit Control Enter. Again, if you see, we have three boxes, one box for each of the race categories. The first box is for first race category, and the second is for second race, and third is for third race category. Then we have the smokers as 1 and non-smokers as 0, and then each of these boxes are still more divided into two parts, or divided by the number of observations in the low categories. So what we can see in the smokers, if you see that birth weight less than 2.5 kg is this blue one, and birth weight more than 2.5 kg is this 0. So we can see that somewhere it is quite equally probable, but here in the non-smokers, what you can see, the distribution of low is quite different. So low is equal to 0 is quite more in the non-smokers. The smokers, low is equal to 1 becomes more equally likely. The difference between the low is equal to 0 and low is equal to 1 becomes lesser in the smokers case. In the race third category, we can see still it is more, it is 50-50, almost 50-50 for the smokers. So for all the smokers in each of the race categories, we can see that the difference between the low categories is very small. But for the non-smokers case, in each of the three race categories, there is a quite different, there is a different separation between the two categories, 0 and 1, and 0 is more than 1 in the low categories. So now we have three categories here. One is the smoke, which is telling us the number of observations for each of the race categories, and then each of these smoke is categories being subdivided by the low. Low is 0 or 1, so each of these is colored by the two colors. So here we have included the three variables, smoke, low and race, and all these are categorical variables. Now what we can do is, we could have also done for the continuous variable. Let's take one more example. Let's plot the density for BWT, which is a continuous variable, numerical variable, and do what you want to do is say, just take facet underscore wrap race. So what you get here is, you get the density plot for BWT for each of the race categories. So you can see the differences in the density plot of BWT in each of the race categories. So this is numerical variable BWT, and this is categorical. Now say if you want to include one more variable, say smoke, you can give in the facet underscore, just write plus and write smoke. You will get more boxes here. Now see, we have different combinations, race and smoke. So up this first row is race categories and the second is the smoke. So first row you can see 1 1 2 2 3 3, and in the bottom row you see 0 1 0 1 0 1, that is the smoke. So if you see the first of the 6 boxes on the upper hand, that is 1 and 0, that is race is equal to 1 and smoke is 0, you get the density plot for this category, BWT. So you can see that this is little bit right, little bit left skewed. It is high detail on the left side. Now if you see the third race is equal to third category and smoke is equal to 0, that is non-smokers, you can see it is almost a normal distribution. Similarly, for the race is equal to 2 category, uh, and the non-smokers, that is smoke is equal to 0, it is again a normal distribution. We can see that in the race is equal to 2 category and the smokers case, we get two peaks, which is a bimodal bimodal distribution of this BWT. We have two significant peaks here. So we can see that for the smokers case we get more than one peak, say one here and one here, and in the last case also race is equal to 3 and 1, we have two peaks. So if you want to see the differences in the density or the histogram, you can plot like this. You could have done also this control C and control V. You could have written, instead of density, you could have written histogram. The rest remains the same, so you can get the histogram. So I think this is clear that how you can use the facet underscore wrap to get more feeling of the data, how the variables are linked, and if there is any kind of pattern in the data. So I will be posting more videos in about this, how you can do different kind of visualizations. So thanks for watching this video. Hello, so in this video I will explain you how to plot a box plot. And box plot is basically for numerical variable, and it is to check the distribution of a single numerical variable. And how you check it, box plot tells about the minimum value of the numerical variable, maximum value, median value, and the 25% quartile and the 75% quartile. So it tells about the quartiles. So it tells about the 0.25 quartile, 50%, 75% quartiles. So you get an idea about how much observations are lying in which range of the numerical variables. You get the value of the median and min and the max value. You get the observations, how they are being distributed across that numerical variable. Say if you have only one numerical variable, say BWT, there you need to plot a box plot. So when you have only one numerical variable and you want to plot a box plot, what you do is you write x is equal to BWT in quotes and y is equal to BWT. In x is equal to BWT you are writing, because you're not taking any x-axis, you will just giving a name of the same column, and y-axis you give the variable values BWT. So if you select this and control enter, you get the box plot. And the box plot, this is not for 3 race categories, it just I have copy pasted, that's why it's written like this, but this is box plot for BWT. Now if you check it, BWT, the distribution you see, birth weight, minimum value is 1000, maximum value is 5000, median value is 3000. Median value is 3000 means that 50% of the data points lie below this 3000 and 50% of data points lie above 3000. So, and this box starting is 25% quartile and this is 75% quartile. So here at the minimum you have 1000, then you have one line is something around 25,000, 24,000, 2400, then you have the line something around 3500, and you have line in the middle which is 3000. This is the median. The line above the median is the 75% quartile, and the line below the median, which is around 2500, is the 25% quartile. So it tells about the number of observations lying in different ranges of this numerical variable. This is just a single numerical variable. That's why we have given in the x-axis is BWT and the y-axis also BWT. Only difference is that in x-axis you are writing the within the quotes just to give the name of that. Now say if you want to see this birth BWT and you want to see across different categories of smoke, how you would do is you take and now you change the x-axis to smoke and y as BWT. Control. Now what you see in the x-axis, you have smoke categories 0 and 1. For 0 categories smoke, you see the BWT, and for the smokers, that is 1 category, you see the distribution of BWT. One thing worth noting is that median value of the smokers, BWT is lesser than the median value of non-smokers BWT. This is what you can see, the median values. You can compare the median values of BWT across the smoke categories. Same thing you could do for the race also, but instead of doing like this, we can just put the race in the facet_wrap as explained before. Now you have 3 boxes for 3 categories, and the first category, race category, second race, and the third race category. You see in the first race and the second race category, the smokers have lesser median values of BWT, whereas in the third race category, the median value of BWT for smokers is higher than the median value of BWT for non-smokers. So just see the first race category. What you see, the median value for the non-smokers is something around 3700, and the median value for the smokers for the first race category is something below 3000, something around 2700. So you can compare these BWT across the different smoke categories and the race categories. So this is how you can see the distribution and the median values of numerical variables across different categories and different variables. So thanks for watching this video.